Exercise 1.3, question number 10. F and G are functions from real numbers to real numbers. Given f of x is mod x plus x and g of x is mod x minus x, we need to find f composition g and g composition f. So we need to find g composition f, f composition g. First of all, let us restate the function. What do you mean by mod x? It is x when x is positive and it is minus x when x is negative. So how will I write f of x? Equals to, I put x plus x if x is positive, because mod x is x when x is positive and mod x is minus x. Here a plus x is there, write it as it is when x is less than 0. Rearrange this, f of x is equal to x plus x, 2x when x is positive and 0 when x is negative. The same idea we will go with g of x equals to mod x is x minus x when x is positive and mod x is minus x. There is a minus x here when x is negative. So wherever mod x is coming, positive I put plus x, negative I put minus x. Simplify and write the answer. G of x equals to x minus x is 0 when x is positive and equals to minus 2x when x is negative. What is my question? I want to find out g composition f of x. That is g of f of x. Keep g as it is. Let me say now x is positive. So for positive we'll do separately, for negative we'll do separately. F of x, when x is positive, what is f of x? 2x. G of 2x I want. Now x is positive. When x is positive, what is my answer? 0. So we get g of f of x is 0. Now I want to find out f of g of x. How do you write it? F composition I forget, I write g of x. F, now x is positive. X is positive. Positive, what is g of x? It is 0. Now I want to find out f equal to 0. So equal to 0 is here. What is my answer? 2x. So I will write 2 into 0, that is 0. So when x is positive, g composition f is also 0, f composition g is also 0. The same idea we will proceed for x less than 0. G composition f of x is equal to g of f of x. G of, now x is less than 0. Less than 0, what is my formula? 0. F of x, when x is less than 0, it is 0. 0 comes here. What is my answer? 0. So G composition f is 0. Same thing let me do. X less than 0, but now I want f composition g of x. F of g of x. F of. Now I am less than 0 and g of x. Less than 0 and g of x. What is my answer? Minus 2x. Now I must go to f. Here f is. And I want less than 0. Less than 0 under f, my answer is 0. So this I get 0. So in all the 4 cases, whether x is positive or negative, Whether it is G composition F or F composition G, my answer is only 0. It is not so in every problem. Here it so happens that all the answers are same. Exercise 1.3, question number 11. Prove that F plus G composition H equals F composition H plus G composition H, where F, G, H are real valued functions of R. So let us start with LHS. F plus G composition H of X. When I want to prove, let me put H of X. How do I write this? F plus G of H of X. The next step, distributive law, we can multiply F of H of X plus G of H of X. F of H of X, I can write F composition H of X. G of H of X, I can write G composition H of X. We started with F plus G composition H. We ended with F composition H plus G composition H. And this is the RHS. So we have shown F plus G composition H equals F composition H plus G composition H. F, G, H are functions from R to R. F plus G composition H is also a function from R to R as given in the question. Now the second part of the question is prove that F plus G composition H is equal to F composition H plus G composition H. So we need to show LHS. We want to prove that F plus G composition H equals to F composition H plus G composition H. So this is over. Second part is what can you say about F composition G plus H? F composition G plus H. So we have to find out the answer. What will be F composition G plus H? Let me start with X. So this we have proved. F composition G plus H of X is F of G plus H of X. This I can rewrite F of. What is G plus H of X? G of X plus H of X. That is, we can put it in F of G of X plus F of H of X. What is F of G of X? It is F composition G of X plus what is F of H of X? It is F composition H of X. So we started with F composition G plus H. We ended with F composition G plus F composition H. So let us take and write F composition G plus H equals to F composition G plus F composition H. Are they equal? Here it is plus first, composition second. Here composition first plus second. Right and right are not equal. So we will declare F plus G composition H is not equal to F composition G plus H. F, G, H order doesn't change, but here plus first composition, here composition and inside plus we have. So they are not equal. So they have given two cases in the problem. We have shown each separately and we have also shown this and this are not equal. Exercise 1.3, question number 17. The function for exchanging American dollars for a Singapore dollar on a given day is f of x is equal to 1.23x. X is the American dollar. When I convert f of x, we call Singapore dollars. Now, Singapore dollar to Indian rupee, it is given as G of Y, that is 50.50Y, where Y is the number of Singapore dollars. This tells me f of x is Singapore dollar, and this line tells me Y is the Singapore dollar. And G of Y, as I convert, it becomes Indian. Now the question is, from American dollar to Indian dollar, how will you convert? So we need to give the expression. From American dollar to Indian dollar. Do not see this operation. Understand in this way. American, it was X. As I put it, Singapore, it became f of x. When it goes on here, Indian, it is G of Y. So G of, what is Y actually? Singapore, they said Y. But we have found out it is f of x. So what is Y we call? G of f of x. So Indian rupees I want from American dollars. My answer is G of f of x. It was American when it was x. As I convert, it became f of x in Singapore. When it comes to India, it is G of y. What is y? Y is nothing but f of x. So to Indian, my answer is G of f of x. So to find G in terms of x, let us write down G of y equals 50.50y. That is G of f of x I want. So 50.50 into, instead of y, I must write f of x. What is f of x? 1.23x. This is multiply 50.50 into 1.23 into x. Find out the answer. As we multiply, we get 62.115x. So in a particular day, you want to convert an American dollar to Indian rupee. X is the American dollar. Indian rupees will be 62.115x, and that is the answer. So this is G of f of x. Exercise 1.3, question number 12. F is a function from R to R. R stands for real numbers to real numbers. F of x equals to 3x minus 5. Prove that f is a bijection and hence find f inverse. See, there are two methods. Let us do by the second method, which is little bit comfortable. F of x is equal to, so take that as y equals to 3x minus 5. From this, rearrange and find what is x. So this will be y plus 5 equal to 3x, or x is equal to y plus 5 by 3. Call this function as g of y. Let g of y equals y plus 5 by 3. What is f of x given to us? F of x is equal to 3x minus 5. Let us find out f composition g and g composition f. Suppose I am able to show these two are identity functions. I can immediately declare f and g are inverse of each other and f is a bijection, and that is the idea. So we need to find f composition g. F composition g, g comes, I must write only y. So f composition g of y can be f of g of y. It is f of, what is g of y from here? Y plus 5 by 3. What does f mean? 3x minus 5. 3 into, instead of x, put this bracket. Y plus 5 by 3. Instead of x, put y plus 5 by 3 minus 5. 3 and 3 cancels. Y plus 5 minus 5, 5 cancels. I am left with y. I started with f composition g of y and ended with y implies f composition g is nothing but I. Because here there is a y, this is nothing but I of y, or I will say f composition g is an identity function. Similarly, we'll find out g composition f. Because f is coming, put x equals to g of f of x. This is g of. What is f of x? F of x is 3x minus 5. What is g actually from here? Y plus 5 by 3. Instead of y, put 3x minus 5. Y is nothing but 3x minus 5 here, plus 5 by 3. 5 cancels. 3x by 3 and that is x. So I started with g composition f of x. I ended with x implies it is identity. So g composition f is also I. F composition g is also I. G composition f is also I. These two together tells me f and g are inverses of each other. So we will say g is nothing but f inverse. G, we will write f inverse. F composition g is I, g composition f is I, together imply f and g are inverses of each other, or I will say g is nothing but f inverse. What is g of y? We have written g of y is y plus 5 by 3. Wherever y is coming, replace by x. So replacing y by x, we get f inverse of x is equal to, wherever y comes we are putting x. So it is x plus 5 by 3. My question is f inverse. I have found out whenever inverse exists, I will immediately declare f is a bijection. So this implies f is a bijection. What do you mean by bijection? It is 1, 1 and on 2. So we are able to show f inverse implies f is a bijection. Bijection means 1, 1 and on 2. Exercise 1.3, question number 19. Y equals 5x minus 160 by 9. Formula to convert Fahrenheit to Celsius temperature is y equals 5x by 9 minus 160 by 9, which is rewritten as y equals 5x minus 160 by 9. Find the inverse of this function and determine whether inverse is also a function. Same procedure as that of the previous problem. First of all, from here, find out what is x. So cross multiplying, 9y equals 5x minus 160, or bringing 160 to the other side, 9y plus 160 equal to 5x, bringing 5 down, x is equal to 9y plus 160 by 5. Call this as g of y. So we assume let g of y equals 9y plus 160 by 5. Now, what is f of x given? This y. That is 5x minus 160 divided by 9. We need to find F composition G and G composition F. What is F composition G? G comes, I have to put Y equals to F of G of Y. F of, what is G of Y? 9Y plus 160 divided by 5. What is F actually? 5x minus 160 by 9. So, 5 in the place of x, put this bracket. 9y plus 160 by 5. 5 into x place we are putting this minus 160 divided by 9. Simplify this. 5 and 5 cancels. 9y plus 160 minus 160 divided by 9. 160 cancels. 9y by 9. 9 cancels. So, F composition G of y equals to simply y, I will write identity I of y, or I understand F composition G is equal to I. The same manner, let us find out what is G composition F. G composition F is equal to, so since it is F, let me put x. So, G composition F of x is equal to G of F of x. That is G of, what is F of x? 5x minus 160 by 9. And what is G actually? 9y plus 160 by 5. 9 in the place of y, put this 5x minus 160 by 9 plus 160 divided by 5. 9 cancels. 5x minus 160 plus 160 by 5. 160 cancels. 5x by 5 cancels. I get x. So, I have found out G composition F of x. I get x implies it is identity. So, G composition F is nothing but identity I. These two together imply F and G are inverses of each other. So, I am able to say F inverse of x is equal to, from G of y, replace y by x. Replace y by x in G of y, because G is the inverse of F. So, what is F inverse of x? 9x plus 160 by 5. Both are functions and both are bijections also. So, let us write F and G are bijections. When do you say bijection? Whenever inverses exist, we can call them as bijections. Bijection meaning it is 1 as well as on 2. Coming back to the question, what have they asked? Find the inverse of this function. We have found out the inverse. Determine whether the inverse is also a function. Yes, we have shown F and G are bijections. So, both are functions only. F inverse of x is also a function. And it is simply not a function which is 1 and on 2 also. Remember. So, we are able to replace y by x in G of y to get F inverse of x. F inverse of x is 9x plus 160 by 5. Since we have shown both are inverses of each other, both are bijections and both are 1 and on 2. The word bijection implies 1 and on 2, and the question we have completed fully. Exercise 1.3, question number 20. A simple cipher takes a number and codes it using f of x equals 3x minus 4. Find the inverse. First, let us check that inverse is also a function. What is the procedure? Take y equals 3x minus 4, y plus 4 equals 3x, or x is equal to y plus 4 by 3. Call this as g of y. Now we need to find out f composition g of y. F of g of y. That is f of. What is g of y? Y plus 4 by 3. What is f actually? 3x minus 4. 3 into y plus 4 by 3. In the place of x we put this minus 4. 3 and 3 cancels. Y plus 4 minus 4 cancels y. So I am able to show that f composition g of y is I of y, or f composition g is I. The next step, find out g of f of x. That is g of f of x. G of, what is f of x? 3x minus 4. What is g actually? Y plus 4 by 3. Instead of y, put 3x minus 4 plus 4 by 3. Minus 4 plus 4 cancels. 3x by 3 is x. So I am able to show g composition f of x is equal to I of x. Simply x comes, write it as I of x. I stands for identity. So g composition f is equal to I. These two together show me f and g are inverses of each other. So I am able to show g is equal to f inverse. Both are bijections also. F and g are bijections. When they are bijections, we mean they are 1, 1 and onto. They are 1, 1 functions as well as onto functions. So we will write what is f inverse of x. In the place of g of y, wherever y comes, replace by x. So my answer is x plus 4 by 3. We have completed finding the first part of the question. What is the second part? Find the inverse, that is over. Check the inverse is also a function. Yes, we have proved it is a bijection. Verify the symmetrical property about the line y equals to x. Whenever we say two functions are inverses of each other, the line y equal to x will be symmetrical to both. So let us draw, that is plot the two lines. Check whether it is symmetrical about the line. As we plot, f of x equals 3x minus 4, put x 0. We get 0 minus 4. Put x is 1. 3 into 1, 3 minus 4. My answer is minus 1. Put x is 2. 3 into 2, 6 minus 4. My answer is 2. Same way, let us work out g of, that is f inverse of x. What is f inverse of x? X plus 4 by 3. So put some x value, find out f inverse of x. Since this is divisible by 3, put convenient numbers for x so that it is divisible by 3, easy for us to plot. First let me put x is 2. When x is 2, 2 plus 4 is 6, 6 by 3 is 2. Put some other value, say x is 5. When x is 5, 5 plus 4 is 9, 9 by 3 is 3. Two values are enough. Let us plot and find out the answer. 0 minus 4 will be plotted here. This is 0 minus 4. 1 minus 1, 1 minus 1. 2, 2, 2, 2. So this is the point. So let us join all these 3 points. So this is f of x. The dotted line tells me y equals to x. What is y equal to x? That is a middle line in between x and y axis. 1, 1, 2, 2, 3, 3, 4, 4 like that it will go, and that is the line y equals to x. My question is, I want to show symmetrical property about the line y equal to x. So I want to draw the two lines and check whether they are symmetrical about this line. Now coming up to the second line, it is 2, 2. This is the point 2, 2. 5, 3, 5, 3, somewhere here. Join this. For drawing a line, minimum 2 points are enough. So we have drawn the second line. This is f inverse of x. Now you can check it is symmetrical about the line y equals to x. So we have drawn f of x, f inverse of x. Show that it is symmetrical about the line y equals to x. And whenever two functions are inverses of each other, they are nothing but lines symmetrical about, lines or curves also symmetrical about the line y equals to x.